Hello everyone, my name is Ehsan Abbas-Najjar and I'm from the Australian Institute of Machine Learning at the University of Adelaide. Vision and language tasks have been successful, but they typically exploit biases and irregularities in the data to achieve high performance instead of understanding the underlying visual and textual content. To tackle this problem, we consider counterfactual, which are unobserved scenarios. You can consider for VQA, for example, that you can have questions that are never asked about the image and are not existent in the training set. We need to consider causal model in which there is an exogenous variable governing the generation of the questions and images. This is a typical graphical model for a VQA, for example, that you can see we have questions, images, and their corresponding embeddings and the ad. By our interventions or by replacing a counterfactual question, we change the graph structure uh, and replace the given question with the one that we've generated, and we reason about the answer that it may have. Formally, we can define this posterior distribution over the exogenous variable given the questions and images and answers. With that definition, then we can easily compute the posterior. We can then reason about the loss function. In the first line, you can see the typical expected risk minimization. But because now we have different questions or images, we have to consider different distribution, and we can use we can weight the loss based on the proportion of the distribute or the ratio of these probability distributions. We can see that if we consider that this principle for image manipulation, we can get state-of-the-art result. We can get significant improvements compared to the baseline. Similarly, for sentiment analysis, which is a text classification problem. For VQACP, we see that it's a considerable improvement. Uh, for example, for other, which is the important one and hard to improve. VQA V2 is a special case where we don't have a large margin of improvement, and that's because it's easy to exploit the regularities in this data set instead of really reasoning about the final answer. We can use that for navigation as well. With the generalization ability to observe from our approach, we believe counterfactuals would be one of the approaches that can significantly improve vision and language tasks.